All right, peeps, let's go ahead and do practice problem 1 in the practice section. So I'm going to show you how to do it, and then you could do the rest using this as an example. So the first thing I want to do is make sure I know what I'm doing. I got to identify independent variable and dependent variable, okay? Then I'm going to create and label a scatter plot. So basically we're going to graph some points here, and then we're going to answer these questions. So number 1. Says the area of a square is determined by the length of a side of that square as shown in the table below. So the key here is this idea. The area of the square is determined by the length of the side. So in other words, in order to understand the area of the square, we have to first know the length of the side. So that means that the area of the square needs or is dependent on the length of the side. Okay? Which in other words means the independent variable is going to be the side length. Okay? So in other words, this has to be given to you. There's nothing here there's nothing else we need to figure out the side of a square. On the other hand, the dependent variable is the area. Okay? Because in order to figure out the area of the square, we need to know the side. So the length gives us the area. All right? So we'll put here the side length, we'll put S for our variable, and for the area, we'll put capital A. Okay? So now let's look at the chart or the table we have here. In IM1, you learned about input and output. So we'll call this guy, he is the input, he is the output, okay? So you can think about independent and dependent variables as input and output. The output or the dependent variable is determined by the input, the independent variable. So input and independent kind of go together, okay? Your output is always based off your input, okay? So these are independent numbers. They have to be given to you. Now these independent numbers determine the area. So in order to get 4 here, we had to know 2, okay? All right, so now that we labeled, we always remember that your independent variable goes at the bottom. So this is of the graph. This is where the independent variable goes. Okay, in this case, it is the length of the side. All right, and in this case, we are using, if you look at our chart, we're using centimeters. So I'm just going to denote that using centimeters. Okay, now your dependent variable is the area. So this axis represents the area of a square, and this is going to be in, if you look at the measurement, centimeters squared, because it's 2-dimensional. Okay, and now we're going to number this. So we have to have these numbers coincide with these numbers. If you notice, I could just use 1, 2, 3, 4, because it only goes up to 9. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now, for these numbers on this axis, we can't go 1, 2, 3, 4, because it's going all the way to 81. So you have to figure out what can we use as the unit here. So we have to reach 81. I think we should go by tens. So 10, 20, 30, all the way up. So this is no longer by ones. This one is by tens. Okay. So now all we got to do is start plotting these points. So my independent or my input is 0, which is this axis. So we're at 0. And my output, when I input 0, I get 0. So my first dot will be here, 0, 0. Second dot would be 1 on the x-axis or the independent axis. So 1, when I plug in 1, it gives me 1. So we kind of have to estimate that. It's going to be very close here. So that is 1, 1. The next one is when I plug in 2, I get 4. So 2, and then 4 is about halfway. Okay. And then when I plug in 4, I get 16. And hopefully you're getting the hang of this. So 4, 16, again halfway, about right here. And then the next one we have is 749. So 749. It's close to 50. And the last one we have is 981. So 981. 981. So 81 is close to 80, which would be right here. Okay, and that's my scatter plot, and I use the input-output table to figure it out. Okay, what is the length of each side of a square that has an area of 36 centimeters? Mark this point on the graph. Okay, so I'm going to do a little bit of geometry here. So remember, we have a square. And to find the area, it's equal to length times width. So I need to plug in, remember, all sides of a square are equal. So what number would I multiply here? So it's going to be length times width. And remember, because it's a square, these two numbers have to be the same. So when I multiply these two numbers, they should give me 36. Okay? And hopefully that answer is pretty obvious. So the length of the square, so the side of the square or the length of the square has to equal 6. Okay? How did I get that? Well, we take 36 and then mathematically we are just taking the square root. Because what the square root says is what two numbers multiplied to itself give me 36, and we can say, well, the two numbers that multiply to themselves to give me 36 is 6 times 6. So in other words, the square root of 36 is 6, and that gives us our side length. Okay? What does the point 749 mean in this situation? So remember, we get these points from the input, output, independent, dependent. So this is the independent, and this is the dependent variable. And if you look, the independent represents your side. So 7 is the side length of a square. Okay, that's for this guy. And what does 49 mean? Well, what 49 means is this. If 7 is the side length of the square, then the square has an area of 49 centimeters squared. So this statement here, 7 comma 49, is just not numbers, because it is related to the independent and dependent variables here. So when my square length is 7, when my side is 7, that means my area has to be 49. Okay, and that's how we would read that. All right, hope that helps.